Hello and welcome back to College Algebra MAT 150. In this video we will discuss tables to graph and intercepts from section 1.1. So as we were mentioning in the last video, the graph of an equation containing the variables x and y is the set of all points xy in the coordinate plane that satisfy the equation. Namely, it's the set of all solution points for the equation. So xy, so solutions in a two-variable equation are points. So for example, let's see which of these two are solutions to this graph. So are solutions to this equation. So we have 2x plus 3y equals 18, and let's test negative 5, 7. 2 times, and again, this is always, the left is always the x, the right is always the y. So 2 times negative 5 plus 3 times 7. And let's see if that turns out to be 18. 2 times negative 5 is negative 10. 3 times 7 is 21. And negative 10 plus 21 is 11, which is distinctly not 18. So that's not a true equation. So not a solution, which means it's not a point on the graph. All right, but what about 3, 4? Well, if we plug 3, 4 in, so 2 times 3 plus 3 times 4, does that equal 18? Well, 2 times 3 is 6, 3 times 4 is 12, and 6 plus 12 is in fact 18. So this is a true statement, which means that 3, 4 is a solution. So is a solution, which means that it is a point. So 3, 4 is the point is a point on the graph of this equation. All right. So this gives us a way, and it's basic, but it is not recommended. But if all else fails, this is a reasonable way to try to get a graph. We will go through many other ways, and I don't recommend doing this way unless you just completely whiffed and you have a complete, this is the complete backup plan. But we can make a table. And so we're going to try to graph this, x squared, y equals x squared minus 4. We're going to do so by making a table. So notice from up here, a solution is just a point. So what we can do is we can try to plug in an x value and see what comes out as a y value, and then that would be, since we did it, is going to be a point. It is a solution. So let's do this over here. So x, let's let y equal x squared minus 4. So that's the equation. So we're going to pick an x. So we get to randomly pick these values. Let's pick like negative 2, negative 1, 0, 1, and 2. And then we can just plug them in. And then we'll have both an x and a y after we get done plugging them, and we can write them as a point. This is just an extra step to remind you what's going on, but let's get to it. So we've randomly chose x values, and we're going to plug them in and see what happens. So negative 2 quantity squared minus 4. So that's negative 2 squared is 4, minus 4 is 0. So then we have an x of negative 2 and the output of a y of 0. So negative 2, 0. Plug in negative 1 squared. Well, negative 1 squared is 1, minus 4 is negative 3. So we get negative 1, negative 3. 0, when we plug that in, 0 squared is 0. Minus 4 is negative 4. So 0, negative 4 is a point. When we plug in 1, 1 squared minus 4. 1 squared minus 1 is 1. Minus 4 is, again, negative 3. And there's a little bit of symmetry going on here. When we plug in 2, and we square it, we get 4 again. Minus 4 is equal to 0. So 2, 0. So now we have 5 points that we can plug in. So let's do that. Negative 2, 0. It's right here. Negative 1, negative 3, which is right here. 0, -4, which is down here, 1, 3. Again, when these points are off the axes, I usually like to label them. I will try to always remember to do so. But here we got 1, 2, so this is 2, 0, and this is -1, -2, 0. And then we have these 5 points. And for our purposes, especially early in this class, we're mostly just going to be dealing with functions that are sort of smooth and continuous. And because of that, we can sort of just try to smoothly connect these things. And we get this graph right here. Okay. All right. So we're going to talk about a better way, a more efficient way to graph this in the future. But for right now, this is a reasonable choice. And it further leads in as a good discussion point for our next topic, which are intercepts. So the x-intercept is where the graph crosses or touches the x-axis, and the y-intercept is where the graph touches or crosses or touches the y-axis. And usually given by the points x. So for your x-intercept, the x has a number, but it's 0 for y. And for the y-intercept, x is 0, but we have some number for y. And if we look at our graph from on the other page, how many intercepts do we have? Well, we have 1. This is an x-intercept because it crossed the x-axis from this graph. This is an x-intercept. So we have those two x-intercepts, -2, 0, and 2, 0. And then we have a y-intercept down here at 0, -4. Okay? So interestingly, there's usually a way to solve and find these intercepts without actually graphing first. And what we do to do that is for the x-intercept, plug in y equals 0. Coming from this point right here, that's how they usually look. So because y is always going to be 0 for x-intercepts, we plug in 0, and we're now down to an equation with one variable, which is often solvable. Similarly, and so then x0 is the x-intercept. And again, I want to emphasize intercepts are points. Okay, they are not just x equals or y equals, they are points. So similarly for the y-intercept, we plug in 0 for x and then solve for y. And then we get the points 0, y, or usually it's just going to be 1 point. Not always, but usually for our purposes. And I want to say this as a way to hopefully help you memorize it. When you're trying to find x-intercepts, plug in 0 for the opposite variable. When you're trying to find y-intercepts, plug in 0 for the opposite variable, namely x equals 0. Okay, so I hope that helps as a way to memorize. So for number 1, let's do the same problem we just did. Okay, but let's try to find the intercepts via the equation. So first, let's start with the x-intercepts. That's usually what I do. We let 0, we plug in 0 for the opposite variable, so y equals 0. Excuse me, sorry about that. All right, so y equals 0. So 0 equals x squared minus 4. And then we solve. For right now, there's 2 methods. You could factor and then solve. I'm going to just show you the square root method. So we're going to isolate the x squared when you can. Can't always do this because there may be more terms with x in it than just the x squared term. But then we have x squared equals 4. I am flipping it as well. But we have x squared equals 4, and to get rid of a square, we do the opposite, which is square rooting. And we do that, if we do it to one side, we do it to the other. And mind you, when you introduce a square root, you should also introduce a plus minus. There's some technicalities there, but for right now, once you just have x, the other side should have a plus minus if you got rid of the square with the square root. And what's the square root of 4? Well, it's 2. And as a reminder, whenever you see a plus and a minus, that really means you have two solutions, one with 2 and one with negative 2. So since we have two solutions, we should have how many intercepts? 2 intercepts. 2 is the x. So remember, points are always x then y. So 2 is x, y is 0. That's one intercept. And then now with the negative. So negative 2, y is 0. All right. So this is the x-intercept. Again, you could factor and solve via factoring. Technically, you could also use the quadratic formula if you wanted to at this juncture. Seems a little excessive there, but you could. Also, we need to do the y-intercepts. Again, to find an intercept, you plug in 0 for the opposite variable. Apparently my pen is dying on me, so let's change that. Change color here. So x equals 0. And so y equals 0 squared minus 4. 0 squared is 0. And we get 0 minus 4 is negative 4. Again, write this as a point because it's an intercept. So again, it's always x then y. So in this case, x is 0 and y is negative 4. And we have the 3 intercepts that we saw on the previous page. 1, 2, 3. 0, negative 4, negative 2, 0, and then 2, 0. All right. For the next problem, we're going to do the same thing. We're going to find the x-intercepts and the y-intercepts. You could do the y-intercept if you wanted to first. But I usually do the x-intercepts because it's more complicated. Further, a lot of times if you get 0, 0 from the x-intercept, that'll also be your only y-intercept, often, in certain cases for functions that we will discuss in the next section. So I usually do x-intercepts first, again. Set 0 equal, plug in 0 for the opposite variable. So we have 2x plus 3 times 0 equals 18. 3 times 0 just goes away. So 2x equals 18. We can just divide both sides by 2, and we have x equals 9. What is a intercept? It's a point. So the point is always x then y, and we have 9 is x and 0 is y. So 9, 0. Now let's do the y-intercept. We set 0 equal for our opposite variable. And then we have 2 times 0 plus 3 times y equals 18. Well, that goes away. And we're left with 3y equals 18. We can divide both sides by 3 to get y equals 6. Again, intercepts are points. And points are always written x then y. X is 0, y is 6. So 0, 6. So these are the two. So this is the x-intercept and this is the y-intercept. And those are the only two intercepts for this graph, for the graph of 2x plus 3y. That concludes part 2 of section 1.1.